Hello, everyone. I'm glad to be here to introduce my lab research on Mongolian plateau. Today, my talk have three parts, and all these parts were closely connected with Mongolia's 1 billion tree. First will be remote sensing monitoring at a regional size and ground monitoring at some key site. And our center, China-Mongolia Desertification Control Cooperation Center. First, we want to bring out why we're doing this work. Mongolia, most of the landscapes are very beautiful and nature. But in Inner Mongolia, we're different because we have the population in Inner Mongolia 8 times bigger than that here in Mongolia. So most of the land in Inner Mongolia are maintained by human beings. They change the desert into rangeland, farmland, and protected regions. So when you go to Inner Mongolia, you will see all the desert change like this. They are shared forest and farmland. All this begins from 2021 because there was a very huge desert dust storm blowing all the plateau. Even in Beijing, the Forbidden City are covered by the dust. So our president initiated the new 3 North project to protect the northern part. And of course, we want to cooperate with Mongolia. So the first part will be, we need to know what's the condition now and what do we have, especially the nature resources. We have used satellite data to calculate the NDVI. This may be the greenness of the Mongolian plateau. We will find that even the desert, but right now, the greenness of this plateau is also expanding. So the trees are becoming more and more, but the desert is still expanding. And precipitations, especially in north and east of the plateau, annual precipitation is increasing. This is good news for us, and I will have some other result below. And the evaporations, because there's a research newly published on Science that says that with the climate change, the whole plateau is warming up. So the plateau is warming up, and the evapotranspiration also going up. It will consume much more water. And the soil moisture, because we want to plant, if we want to plant 1 billion trees in Mongolia, we will need to know how much water can be used by these plants like soxo or tamarix, whether they can live in this land. And I take some snapshots about the lakes on this plateau, maybe in Mongolia or Mongolia. We found that all these lakes are changing sharply. Before 2020, we found that in Inner Mongolia, because all the lakes and the land are controlled by human beings, we forbidden local people to use groundwater. We can use irrigated land with water from Yellow River. And we found that in Mongolia, all the lakes are shrinking. But in Inner Mongolia, the lakes are expanding. But things changed very quickly in these 2 years because climate change. The annual precipitation is going up in the whole plateau. We found that the past 2 years, things totally changed. In Mongolia, all the lakes are expanding, not only the big lakes, but also the small lakes, because of climate change. We thought that maybe 5 years ago, we think that climate change will make this land more drier, but in fact, no. We're getting more weight, also in Mongolia. And we compared lake size in 1990s to 2024. We found that generally most of the water bodies are increasing thanks to climate change. And not only, maybe some mineral small lakes are shrinking. So right now we can have a conclusion that water is enough for us. Then how we use these waters? We just talk about the water above the land in the whole Mongolian plateau. The water is shrinking. The average number maybe 3.3 millimeter a year. But in Mongolia, because there are more farmland and rangeland, we consume more water in Mongolia. But here we consume less. But for the whole plateau, water is shrinking, groundwater. So we want to find out which region is shrinking deeply, sharply. Then my lab had to find out all the special changes. We found that in the west and the south of the regions, we consume more water, just as where we stand. And what factors control this influence on the groundwater storage? This take us a thought. Which region the groundwater will control the plant growth? So we bring an idea of ecosystems. If we want to plant 1 billion trees in this region, we'll have to find out which region the plants can use the groundwater. Then we don't need to maintain it. We just let these plants grow by themselves. If the root is deep enough, it will absorb water from the groundwater. So my lab have found out that most of the south and the east regions are groundwater dependent ecosystems. This is good news for us. In this region, we plant some local plants like soxo. It will rain feed, and the groundwater will support them. So then maybe remote sensing is a big visions. We need to precisely know the exact site, how much water we can use. So I take out the ground monitoring in Mongolia, because it's easy to do that experiment. We carry out in Muas and Horchin sandy land. And my lab designed these instruments to monitor how much water can be recharged to the deep soil. So only water which are percolated into deep soil can be stored there and used for plants. I monitor like bare land and forest land and farmland. Then we find out that in grassland and desert land is a good land for recharge. Most of the water in these regions can recharge into the deep soil and stored there. But for forest and cropland, although precipitation have been consumed, and even we need to irrigate it with groundwater. So if we want to green a region, we need to calculate precisely how many trees we can plant it. We can't say this region we green the whole the region. That's impossible. We need to keep bare land. And my team have been working on this for quite a long time and find out the model, and we build up a model to calculate in a whole region how much land for planting and how much land to keep it as nature. And the most importantly, we will plant it, if it is true, we will plant 1 billion tree in Mongolia. And how these trees consume water, for my mind, I would like to introduce local plants. So my team has monitoring like soxo and tamarix, how much water it will be consumed. We found that tamarix and soxo is much more good for this land because it will consume very little water. And maybe these days we can walk around and take a look. We found that trees planting here is not that good because we see few high trees here because we need to know when we have to watering or irrigating these plants. So my team have monitored when to irrigate these trees will get a biggest income. We found that at night. So if we want to this soxo or tamarisk going well, we need to irrigate it at night. It will be more good. And the influence of the meteorology factors on this plant's consumption will be very rare, but mostly PAR was the most important factors to control the tree growth. And the last one, I want to introduce this center for all of you, because right now, Chinese government, this was launched by CITICA. I worked for that region, that institute for quite a long time. And we welcome every one of you in Mongolia, every institute, agency, and researchers to join us. Because this homework, we take it as homework assigned by your former Prime Minister and President and my President. Well, how we deploy this plan, we limit as 1 building in UB, 3 demonstration located in UB, Zamwood, and east part, and 7 monitoring stations. These stations we just numbered 7, but haven't decided where to set it up. If you institute here, you bring good ideas up. I think maybe just as here, South Gobi, we can set it here. Why are we doing this? We want to find out how much resources exactly here, and then we can plan and or deploy the right way. So, okay, that's where I want to introduce my research and my work to all of you. Thank you.